Hey guys, welcome to another video. So we're going to build the pond pumping power station, the PPPS. We're going to build it here in the shop just so that I don't have to be messing with it out at the cabin, and then bring it out there. And this is a good system for anyone who just wants to learn how to make a basic solar setup. Even though this happens to be for a pond, it's exactly the same. The only thing that's different is I'm not going to have an inverter, but the way that we're doing this with bus bars, it's super easy to add an inverter after the fact if you want to. So anyway, let's get started. All right, so we're going to work our way from the solar panels all the way through to the battery. So I think that's not necessarily the easiest way for me to build this, but I think it's the easiest way to understand. So the very first thing we've got to do is we've got a 30 amp breaker here. That is going to be protecting all the wire that comes from the combiner box. We're not going to do the combiner box in this video because it's going to go outside of this enclosure. But that basically protects the wire that comes from the box down into the charge controller's inputs. So we need to make sure that this thing doesn't move around. So I'm going to pop a couple screws in here. See if we screwed it to the table. No, it didn't. I can already tell I'm going to run out of short screws. Alright, that's in there solid. I think we'll only do 2. And these are midnight DC breakers. They can go up to 150 volts. They have a plus on one side and a minus on the other. So that means the direction of the current flow input has to be on the plus side, output on the minus side. Actually, and we'll just go ahead and fasten our charge controller. These are all just barely biting through. All right, let's take our cover off here. So that's a nice feature. Let's zoom in so you can see this a little better. All right, zoomed in a little bit. So you can see that these, you actually screw into metal rather than plastic. It's kind of neat. Toothpicks. Give you free toothpicks with the purchase. Anyway, the negative is the output. This one over here is our 30 amp. So we've actually got to come up and loop around. What gets kind of annoying with these is just trying to make everything work the way that it should. You end up doing some wire gymnastics. Let's open that up. Open. I thought about reversing this, but then the off and the on letters are upside down, and I thought I might get confused, and this is the way I did my other system too, so we just kind of have to loop around. And so we need to go in, this is our PV plus, so we basically need to go through this cord grip or strain relief over to there. Through there. I'm using 10 gauge wire for this. Alright, and that's our PV plus. Another nice feature on this is that this cord relief stays with this part when you take off the cap. Like, it's crazy, like companies do stuff where like that would have to come off too. Super hard to install that way. And this is nice. This is a NEMA enclosure, which will be really good for where I put this thing. It's not going to be the best environment for electronics, so it should survive pretty well in that enclosure. We're going to wire the battery positive because it needs to go over through this breaker as well. And so it gets a little confusing because the difference here is the input for the battery positive to the breaker is going to be the opposite side as from the solar, because the power is going to flow from the controller through the breaker and then to the battery. So basically we have to put this through here and connect to this 20 amp right here. And the instructions will want you to go through this different cord relief right here for the loads and the battery wires. So the PV, this has 2 holes, this one has 4. So we're going through this one. And finally, we're going to have to do one more red to the load plus, because we're going to use this to do some cool stuff, lighting control. Just have to get this over into that one. Alright, load plus, battery plus, PV plus. Alright, I moved this around a little bit and I fastened this box that we're going to use at a later time. So now we're going to put our positive bus on. So a bus bar has a lot of advantages, but basically the main thing that it does is it gives you one central place to fasten wires. Using a bus bar also allows you to put your shunt in between your battery and all of your loads really easily. So this is going to be we've already connected our battery plus. So we're going to be coming from this breaker. So we're going to go from the bus bar to this 20 amp breaker, which is protecting the output of the charge controller. And I've got to make a U-turn. Yeah, that shows. Cool. All right, that's tight. So the power is basically flowing from our battery plus, which is right here. It's going up here. It's going into the input of this breaker, or this, oh, I just connected it to the wrong breaker. All right, so we got to move that over. All right, so it's coming from battery plus on the controller. It's going down, it's going to the input of this 20 amp breaker, and then it's coming out and it's going to the positive bus bar. All right, let's fasten our negative bus here. Turn that a little bit, make it gets straight. Battery negative to negative bus. All right, let's get this connected. All right, that's in there. I'm going to screw it in off camera. Now we'll bring this charge controller negative over to the negative bus bar. Now we're gonna fasten this down before it starts driving me crazy. Oh, wrong screws. Screwed it to the table. There it is. Okay. Now we're gonna fasten our grounding bus, and we'll show you why in a minute. So we have a grounding bus on here because since this is a pond and there's going to be water involved, I would like to have not just circuit protection but ground fault protection. Ground fault protection is kind of interesting with DC power. The way it works, it has two breakers ganged together, a 1/2 amp breaker right here, and then just a bigger, this one happens to be 63 amps, but this one can be whatever size you need, and they make different models of it. This one is called, this is the Midnight DC GFP for ground fault protection 63, and the way this works is that this little 1/2 amp comes with a green and a white wire, and you connect it between the negative and the ground on your battery. So we're going to do between the negative bus and the grounding bus, because that will accomplish the same thing. And the way that it does is that in a ground fault situation, you have current traveling back to ground, back to the battery in a path that it's not supposed to go. So it has to go through the ground, right? If it's going through a person, if it's going through anything, it's not returning on the negative, it's returning on the ground. So this detects that current and it cuts off, it's going to cut off the load wire that supplies the load. So it's kind of an interesting, neat way that these things work. And you, obviously, if you guys don't know, I should probably say this, but your battery negative is connected to your ground in most systems that aren't floating ground. This is a low voltage disconnect, and this is definitely important because this thing is going to be running autonomously, and I don't want to fry out my batteries and just kill them. So we're going to wire this now. And this is going to the other side of that ganged ground fault protecting breaker. And then this is going the output side. and then you have to connect this to the negative, so we'll do that. Okay, so this is future Mike here. After doing some more research on this device, I realized that I wired it the wrong way. It has an input and output, and I've read reviews where if you put it someplace where it can capture current in two different directions, it can burn out. So what I've done, I have this right now on the battery wire, so it can be either charging or discharging depending on what's happening. I need to move it over to the wire that powers the loads. In that situation, it'll only be discharging. It'll still act as a low voltage disconnect, but it won't be subject to those multi-directional currents. Even use our same, maybe we'll run that underneath there. Maybe. Alright, so this is all rewired the right way now. You may see it wired the other way in the rest of the video. I don't know how I'm going to edit this back in, so don't get confused by that. But if you got one of these Victron low voltage disconnects, you can't put it someplace where current can flow both directions, like the main battery cable to a bus bar, because it'll supposedly fry it. Okay, so now we're going to wire in this shunt for measuring current. And you can really put these on any negative that you want. We're going to put it in between the battery negative and everything else, because by doing that you basically get the best of both worlds. What you're going to get is an averaging function if everything's hooked up and running. If you've got your solar coming in and your loads going out, it's going to tell you whether you're net plus or net minus on power. But say you wanted to know how much solar you're bringing in, you could pull the fuse on all your loads and it'd tell you that. Or say you wanted to know how much power you were using, you could just turn your solar off and it would tell you that. So that's why it's a good place to put it in between the battery and all of the loads. Or in between the battery and the bus bars, the negative bus bar. These cheap Drock, I've put a couple of these in. I like them, they work great. The only thing I don't like is there's no good way to mount the shunt, so I'm going to drill some holes and use some rivets here. Not some rivets, but some, you know what I mean, some zip ties. So we got to put those in first, like that. These seem like they'll be reasonably strong. Let's adjust the camera. All right, there we go. Pull that through. That was something. I'll do this one here. Alright, so we got our 8 gauge ring terminals. Got some 8 gauge wire here. Cut off roughly what we need, which is not much. And put that in there. Got this thing set to 8 gauge as well, and we will crimp it. Nice. That thing gives a really good crimp. I mean, I can't pull that out. And maybe made that a little long. There we go. That's about as tight as I can get that. We can wire these sense terminals. These are sense wires. This is way thicker than they need to be, but that's just what I have. Crimp these guys. So yeah, I don't have any screwdrivers small enough to connect these sense wires right now, so we'll have to do that later. But we can wire our load center here. So we're gonna go from the positive to this breaker and then to the bus bar. Alright, we're gonna do this over again. Just this thing just kind of got jacked up. From the other side of the breaker to the bus bar. So the plus side, we got to go from the plus side to the bus bar because power is going to be flowing from the bus bar to the breaker, to the loads, and to whatever is using the power. There. Alright, so that's the positive for all of our loads. Do the negative, which is pretty easy because it just has to go from there to there. That's not coming out. We'll be going from here to there. A little curve, so should be enough. Be even more out of the way. So. What I'm going to do is wire in one of the bubble pumps and I accidentally bought a 12 volt pump instead of a 24 volt, so I've got a 24 to 12 volt converter here, and then I wanted to put a motor controller in so that if I want to use less power I can turn the pump down, just because I don't know quite how my setup is really going to handle all this load. I know how it's going to do it on paper, but that's not always the same as how it works out in real life. So if I want, I can turn down this pump and take less power. So we're going to wire in this 24 to 12 converter, and then we're going to wire it into this motor controller, and then the wires that actually power the pump will come out right here. We're going to go from there to there. I'm using 12 gauge wire because this pump may end up being pretty far away. Normally I would run 14. It's about 60 watts at full power. That's nice. It has those clamps so you don't have to use a ring terminal. Alright, negative, negative. I've got this wire that I'm using is what I was running when I ran from my truck battery to the pump that I pumped out the pond with, and that actually killed my truck battery. My truck like doesn't start well now. Not surprising. It's probably a dumb thing to do. Not so hard to get these in when they're on a flat surface. When this thing's on a wall, I like to use the ones that slide in like that. You don't have to take the screw out all the way, but there we go. So connect our converter, voltage converter, to our motor controlled negative. This is actually really nice, this thing. I like the way that it has these ones that clamp the wire. You get a really good connection. This. You can fit pretty big wire in too, if you ever needed to. This can take between, it says 7 and 72 volts. But it says you need a little bit of margin on either side, but that's a pretty wide input range, which is kind of cool. I chose to put this before this because I don't know how this thing would handle pulses of power. I figured it'd prefer a steady 24 volt input, because the way this works is by turning the power on and off super fast. Yeah, and what I figured I'd do, since I accidentally bought that 12 volt pump, I mean I could just return it, but I figure those things probably only gonna work like a year before they break anyway, so I'll just run it till it breaks and I can pull this thing out, or if I really like it I can just get another one. But probably won't, because it's just more practical to run 24 volt in terms of wire runs and stuff. So that's good. So then our output will get connected there. All right, I want to make this. This is going to be the cable that connects to the battery. I don't want to make it too long. It already kind of snakes around a bit, probably like 3 feet worth of snaking around. So I think maybe I'll make it 3 feet long. That way I've got no more than 6 foot of wire run to get from the load to the battery. We'll make our negative same line. I think they gave me I think they gave me 6 gauge negative wire. These are not the same size. Can't read the writing. It's all worn. Yeah, it's 6 gauge. It's funny. I don't think that'll do anything bad. You know what I'll do is I'm going to tape the, I have tons of black left over. I'm going to tape it red, and I'll have 6 gauge in both cases. Got my red. Got my red tape right here. Just do this. Now if you accidentally confuse this for a negative, I don't know, there's nothing for you. I could probably mess it up. We've got to change these to 6. They're set on 8 right now. That's 1-0. Alright, there we go. That's 6. Kind of hard to see. These have been pretty good. I like these, and they weren't that expensive. Alright. And here we go. Let's test it. Yeah, that's definitely not going anywhere. So we don't need I don't need another one on the positive side because right here I've already got it, so that'll go in there like that. Well, it'll go below it. Alright, there we go. Alright, so these are our 6-gauge wire lugs. They're Cellterm brand. I just bought them on Amazon. They sell different diameter holes, and you got to make sure that what you get can fit over your battery terminals or whatever you're putting them over. Like this, these shunts have these huge nuts, so they got to fit on that. That's the wrong one. No, I cut another black. How did I? Maybe I didn't cut it. I guess I never cut that. Shit. Okay. That's our negative to the battery, and everything, all current in some way, shape, or form will flow through this shunt, either into the battery, out of the battery. So this will capture everything. Actually, once I do the charge controller's load, that current won't flow through the shunt, but that's going to be lighting, so it's going to be pretty minor. And this doesn't count amps. This is not sophisticated. It just gives you amps, and it gives you watts and volts, but it doesn't actually keep track of them, so it's not like it matters if I miss some current. Alright, so we can also run the power to this display as well. It actually needs power to work, so surprisingly. So we're going to run these wires here. These are 14, and they don't even need to be 14. I mean, that's way overkill. I'm going to put a 1 amp fuse. That's just all I have. I don't have anything smaller, and it's like having all the wires and the ring terminal sizes, it just gets to be a lot to keep track of and make sure you have. It's tight. That's pretty good. I have fried these before, so don't hook them up wrong. There's not like a safety. You will cook them. All right, this is cool. I found a screwdriver that can kind of fit if I really jam it in there. All right, so we've got sense wire on the battery side, which is this, because this goes to the battery. You can't see that. Let's zoom out a little bit. Okay, so sense wire, battery cable, shunt, battery. So the sense wire on the battery side goes here. So get that in there. And that sense wire on the load side goes here. I'm going to have to turn this over and twist all these wires, but what can you do? And then we're going to have DC positive down here. Don't reverse your polarity. And DC negative, that's got to get loosened too, even though I think I already did. There we go, DC negative there. Let's give all of these a little test. And we will put it right there. And hope that it's not upside down, otherwise we'll have to go like that. I wish I had a power source here. I have a feeling it's going to be upside down. All right, I got a weigh here. This is about 20 volts. So that's the negative. Oh, hey, it's right side up. Yeah, 20 volts. Look at that. That's pretty cool. It's not short anything out here. So it is right side up. So what we're going to do is use some double-sided tape. Put it right there. All right, we only get one shot. About right there. Alright, I've got a bunch of this strip lighting that I put underneath the cabinets, so I'm going to put some of this on here just so that I can flip a switch on if I'm working on it in the dark or something. It's not going to need a lot. I will have to solder it. I'm just going to put it, I don't really know, there's no good, if I put it up there it's going to be blocked or cast a shadow. I'm just going to put it on the bottom. I know it'll be easy to wire that way. I have to zip tie this thing in too. I don't think it's thick enough to fit from the underneath. Not that I'd want to. Or I can use that tape. May have to support it when I flip it, but all right. So we're gonna wire up the bulb on the switch just so it's easy to find if I ever go in there at night. That's tight. Okay. Now this little guy will go up here. This little guy will go down here. Oh, that's the wrong terminal though. That's the negative. It's on there decently solid. Doesn't appear that I've shorted it. All right, now we'll do our positive. We gotta go to our switch. It's always hit or miss when you buy these little terminal connectors, and these ones here are just not that good. Yeah, see, very common issue. They're supposed to be the right size. Sometimes you gotta like clamp the plastic part. Let's try the red. But that should be held against it pretty decently well, so I don't think we need to worry about that too much. That's on decently well too. Alright, we're going to have to test this again to make sure we have a good connection, and I don't think a 1 amp is going to cut it for that. Well, 1 amp at 24 volts is 24 watts. I can't imagine that takes more than 24 watts. So 1 amp will probably be fine. We're going to have to test this again. Oh, shit. That could have been bad. There it goes. Cool. Alright, that works. Charge controller's blinking. Alright, so I can do something else. We're going to set these dip switches. So this one here is solar clock. I'm going to turn that on because I do want that function. It basically uses the sunlight, dawn and dusk, to get an approximation of what time it is. Parallel number 2. So we want that off because what I'm doing is I'm going to use the load circuit. With the load circuit used, 10 amps is dedicated to the load, 20 amps is dedicated to charging. If you put this on, it dedicates all 30 amps to charging. I'm at 24 volts, I don't need that. My panels are like 6 amp max. I could put another one in parallel if I wanted to and still stay at 20. It's on the output side, but still you're almost never getting max power, and I'm going to virtual track, so my panels are going to be all tilted in different directions. That's another reason I went with a PWM controller, is because that supposedly confuses MPPT controllers, and they don't work that well that way, is what I've read. Okay, 24. So number 3 is 24 volt, which we're going to do. So we want 3 on. Number 4. Okay, these are battery type 4 and 5. So we're not sealed. We're going to do flooded profile 1, maybe. Yeah, that's a higher equalize. Lower float. We're going to do that. So when we want that, we're going to have 4 on and 5 off for that profile. My crown battery is like a high equalization voltage. Okay, now 6. So 6 allows you to go for a deeper discharge. I'm from the load. I'm not going to do that. We're going to keep that off because we want this thing to cut off. If it's only lights, it's not important. We want it to cut off if the battery gets low. Alright, so 7, audio EQ, I do want that on. So we're going to put that up, auto equalized. So the equalized charge, you probably know this, but that's a higher voltage charge that brings these cells into better balance, and it burns the junk off the plates, supposedly. PWM disable, we're not going to disable it, so we're going to turn that off. That's in case you're getting some kind of interference, you would turn that on. It doesn't charge as effectively when it's off. Alright, now we can try and figure out this lighting control. So this right here, I believe, there's very small numbers on this, and we can turn this for lighting. And what I want to do is probably have this thing go on. We want this on from dusk to dawn, so we're going to turn this to E. which it's going to be really, I can't even see it, so I know you can't see it on the, so E looks like 2 clicks to the left. So we're going to turn this thing 2 clicks to the left for E. If I can, so we'll get F, E. All right. And if I accidentally too far, it's going to be on dawn to dusk. So it's going to be on during daylight. I'll know if I turned it too far. So that's about it for this thing, I think. Neat little thing, $100. So here's the reason, another reason why I went with this over a MPPT. The next best MPPT that I would buy is the Victron 30 amp 100 volt charger, and that thing is like $225. So for the price of this, if I upgrade to that Victron, I spend $125 extra and I get maybe a 15% improvement over the course of the year. Some people say 30, I think it's closer to 15, especially because my panel voltage is very appropriate. So I'd get a 15% improvement on a 200 watt panel. But if I use that $125 for a panel, I basically get a 50% improvement. So I put that money towards a panel rather than a more efficient charge controller, because the goal is not highest efficiency, it's the most output per dollar. All right, well, I'm calling this project done. It's as done as I can get it right now. We'll have to do some stuff when we get out to the cabin. I hope you guys enjoyed it. I know that's not for everyone, but I figured I'm going to be doing it. I might as well film it. So put it up there for you guys, and I know some of you are really interested in solar, so I hope you liked it. And this probably won't show up in an official video for a while, because I want to finish the stonework on the pond first, and I want to get the solar panels mounted. I'm doing a pole mount, so I got some racks and stuff for them. So I don't know when I'll actually get to that, but when I do, highlights from this video will go in that video, but not the whole thing. But I'm pretty excited about this. I love building this stuff on a mount so that I can just bring it down there and be ready to go. So anyway, I'll see you guys later.